In this video, I'm going to be modeling for you 3 strategies we use when we are looking at equivalent fractions. So equivalent fractions are just fractions that are equal, or when you are using a visual, they take up the same amount of space. So I'm going to show you 3 different strategies that we use that your student needs to be recognizing and comfortable using. So the first one we use is the bar model. So here I have 6/8 already colored in, and they might be asked to give me a fraction that's equivalent to 6/8. So to me, and what I try to notice with my 4th graders is I'm going to do something that works well with eighths. So for us, what we've talked about a lot is fourths and halves. Eighths come from fourths and halves. So let me do some fourths and see if any fourths are equals. Well, if I shade in here, I see that 3/4 is equal to 6/8 because they take up the same amount of space. Now I want you to notice something. I use the same size whole bar here. If I did this, and then I made another one like this, you can't compare those because the holes aren't the same. That's like saying I had half of a small pizza and you had half of a large pizza. We didn't have the same amount of pizza because our whole pizza was not the same. So you have to have the bars or the hole the same size if you are using a visual like this. So there's one example. Now, some 4th graders will go, oh, I bet you that I could do halves because halves work really well because halves made fourths, which made eighths. But if I shade in 1/2, that's less. And if I shade in 2 halves, that's more. So halves and eighths don't have any equivalent fractions. So you're not always going to have something. So you got to kind of try around a few times. But again, I like to go back to denominators that I know work well together. Like if someone gives me tenths, I'm going to try to do some fifths. Or if someone gives me sixths, I'm going to try to do some thirds or 12ths and see if that works. So that's one strategy using the bar model, but make sure that the holes are the same size. The other strategy we use is sometimes 4th graders might see a visual already and they need to pull out equivalent fractions that they already see just in that one visual. So for example, a lot of 4th graders, their eyes go right away to there are 10 spots here shaded in, so they see 4/10 because 4 of the 10 are shaded in. So what we challenge them or push them to do is, what other fractions do you see? And especially if you have an array like this, you could look for rows and columns. So, well, I see 5 columns here, 5 equal groups. So I could use fifths, and 2 of the fifths are shaded in, and since they take up the same amount of space, 2/5 is equal to 4/10. Those are equivalent fractions, okay? So I didn't have to draw anything else. I had to just look at it in a different way. Now, some 4th graders might go, oh, I see 2 rows, so maybe 1/2, but if I moved these up there and erased them from here, it wouldn't be filled in. Like I don't have half and half. So that's not going to work. Halves don't work. But here I do see 4/10 and 2/5. So that can be tricky because they have to change their brain on the way they're thinking about it. One other strategy for equivalent fractions is noticing the relationship between numerators and denominators. And kind of, or 2 numerators and 2 denominators. So what we have noticed, you can look at it in 2 ways. If I already have 2 fractions here, I can notice and say, well, the relationship I see between these 2 numbers is 2 times 2 equals 4, and 6 times 2 equals 12. So since they have the same relationship, the 2 and the 4 and the 6 and the 12, they're equivalent. Or you could also look at it this way. Since 2 times 3 gets me 6, and 4 times 3 gets me 12, also could see them as equivalent fractions. So if you're given a fraction, you want to use the multiplication method, just multiply the numerator and the denominator by the same number, and it'll give you an equivalent fraction. So here I could do 1 times 5 is 5, and 3 times 5 is 15. So 1/3 and 5/15 are equivalent, okay? So these are the 3 strategies that we use. The bar model, trying to change our way of looking at something, and then also multiplication of numerators and denominators, okay? So 3 strategies that they need to be comfortable with using, noticing when they're around them in different problems and whatnot. So Use these when you're needing to.